Okay, we're going to use the Biot-Savart law to derive the equation for the magnetic field near an infinitely long current-carrying wire. And we'll start with the Biot-Savart law, which says that the small contribution to the total magnetic field at point P by the small segment of the infinitely long wire dx is directly proportional to the current in the segment dx, so directly proportional to I. Mu 0 over 4 pi is a proportionality constant. The field is directly proportional to the length of the wire segment dx and inversely proportional to the square of the distance from the wire segment directly to point P. Since we do need the perpendicular distance, not really the distance along R, but we really need the perpendicular distance up from the wire along A, we're going to multiply by sine of theta, okay, to get just that perpendicular component. So our first step here in using Biot-Savart is to get all of our terms here in A and X. Right? So we look at the triangle we've got there in the diagram, and we see that R is the hypotenuse of that triangle. So R is equal to the square root of A squared plus X squared, and that the sine of theta is equal to A over R, so that's equal to A over the square root of A squared plus X squared. So we'll make some substitutions into our formula here. And so we'll substitute out sine theta. So sine theta becomes A over the square root of A squared plus X squared. And then R squared will become the quantity A squared plus X squared. Okay, so now we can do a little bit of combining, and our expression for Biot-Savart becomes dB equals our proportionality constant times I times A dx over the quantity A squared plus X squared to the 3/2. Alright, so now we are really ready to integrate, and what we want to do is we want to add up the contributions from all of the little wire segments dx, sum them all up, and get the total field at point P. So that summation process is our integral, and when we sum up all the contributions at point P from all the little wire elements, we'll get the total field at point P. We'll pull our constants out. Mu 0 is a constant, I is a constant, A is a constant, and 4 pi is a constant. And so we're left with the integral dx over A squared plus X squared to the 3/2.